Okay, so let's get started. We're going to be taking a look at how to program and work with our intake air temp fuel correction table found within our link G5 and G4X programming. When we're working with our traditional fuel equation mode, we find that pretty simple in its calculation. We have our master fuel value, we have our table values here, which are a percentage, and then we also have our map pressure that's factored in to calculate what the injector pulse width should be. That's our base pulse width. Then we add our latency injector dead time here to that value or any short pulse width. That gives us a final corrected injector pulse width. If we've tuned, let's just jump in here real quick in our fuel table. If we tune this entire table out so that we're hitting the desired target lambda we've programmed in our target lambda table, that means that our table is 100% calibrated, everything looks good. Let's assume that happened at roughly 20 degrees Celsius or roughly 60 to 80 degrees Fahrenheit. If we start to get into colder intake air temps or warmer intake air temps, we'll find that our fueling delivery will not be consistent. If the intake air temp goes lower, air density increases, and therefore the values that we calibrated this table with are not going to be accurate. We have to add more fuel. Now, technically speaking, you could jump into the table and make your changes, but then if the intake air temp picks back up again, then you'll find you have to go back in and make another change to the table. In order to avoid doing that, and in order to be able to characterize and being able to compensate for air temperature differences, air density differences, we use our intake air temperature as a means for a compensation table. So in the traditional mode, we can't directly characterize and compensate for intake air temp or air density changes as we can with the model mode. In the last few tutorials previous to this tutorial, we talked about our charge temp approximation table. We talked about our charge cooling coefficient. Those allow the link to be able to have a highly refined math modeling to determine our air density and therefore our charge temperature and therefore calculating an accurate fueling model. When we're in the traditional, it simplifies things, but one of the things it does is strip away the ability for the link to go in and start to make those calculations for us. Now, I do want to mention, if we go back to basics here, we can go in and we can turn our charge temperature correction on, which allows that same type of compensation to be in play with the traditional mode, but it does make things a little bit more complicated. Generally, I leave it off in the traditional mode, and I just rely on my intake air temp sensor compensation table to do the work for me. Let's go in and take a look at where we can find our compensation table so that we don't have to worry about constantly going in here and touching up our fuel table as air temperature changes, as our air density changes. All right, so if we move in here to our fuel trim table, we're going to be our fuel trim page, I should say. Let's go here to our intake air fuel correction. Right now, the IAT mode is off. We want to go here and toggle this to on. Now, when we do this, our IAT fuel trim table populates. The table is set up based on intake air temp at the top, and then on our load axes, throttle position on the side here. Now the values are a percentage modifier, meaning they're going to be either adding or subtracting the face value in the table here to the injector pulse width. So it'll either increase or decrease the injector pulse width based on the intake air temperature picking up, getting hotter, or if it gets cooler, air temp starts to drop, we start to add some fuel. Now, the problem with the values that defaulted in this table is that they're not going to be based on the ideal gas law. The ideal gas law is saying as air temperature changes, there's going to be a mathematical amount that our fueling should change in correspondence to the air temp change. Let's go in and start off with a table that's based on the ideal gas law rather than starting off with the default values here in this table. What we're going to do is right click and go in here to import, say import from file. Let's go to our desktop. Let's go here to our G5 course packet under the calibrations folder and then move down here into our IAT Fuel Comp table folder. Here we find two options. The second option is something we're going to talk about here in a few minutes. This is going to be if you're in your model fuel mode, so the model equation mode, and you're getting heat-soaked intake air temp sensor readings, which can completely throw off that model mode. We would select this option, and I'll talk about how this works and why we want to implement this, or possibly why we want to implement it. But here I'm going to select my IAT fuel trim and click enter. Now we can see the table has changed a bit. It's still TPS versus intake air temp, but now we have 10-degree IAT increments within the table. And the values here are going to be more in line with the ideal gas law. So we want to start off with these values for calibrating and tuning our main table. And we should find, as long as your intake air temperature is not getting heat soaked, it will produce a correct compensation as your air temp is changing, as your air density is changing. The problem is going to be in a lot of vehicles as the air temperature or the intake air temp starts to heat soak from engine bay as the hood's closed. The compensation table here a lot of times has to be modified. So the best way to handle this, taking a look at the way the table is shaped, go in. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.